In Module 5, we're going to take a look at similar figures. But before we can take a look at similarity, we first have to start with talking about ratios and proportions. So let's start off with a ratio, and a ratio is just a comparison of two quantities. So for example, you can compare the ratio of female to male students in a class. You can compare left-handed to right-handed people. You can compare eye color. There's lots of different ways you can compare two quantities. And there are a few different ways we express the ratio. Suppose we're expressing the ratio of A to B. The most common way is to see it as A and then a colon and then B. So the way we read that is A to B. You can also see it written out as A to B as it is in the initial statement. And then the last way you typically can see it is as a fraction, A over B. So the most common ways to express a ratio comparing two quantities. So in our first example, we have the total number of students who participate in sports programs at Woodland Hills High School is 703. The total number of students in the school is 1,850. Find the athlete to student ratio to the nearest tenth. So when you're trying to figure out how to write the ratio, because it says athlete to student, that tells us that A equals our athletes and B equals our students. Okay. And because we are being told to find the ratio to the nearest tenth, the way we want to write our ratio to get the best answer is going to be as a fraction. Because if I leave it as the 703 to 1,850, that doesn't help me write it as a decimal. So remember, the nearest tenth is 1 decimal place. So when we set up our ratio initially, it's going to be 703 over 1,850, A over B. And we also, if I were leaving this as a fraction, I would want to try to simplify this ratio as much as possible. Because if I say 703 to 1,850, it's not the same as saying for every one athlete, there are 20 students. So we do like to simplify ratios as much as possible as well if we're leaving them as a ratio. So when I divide 703 by 1,850, you're going to get the decimal 0.38. That is the exact decimal. But because it asks me to round it to the nearest tenth, that would be 1 decimal place. So I need to look at the second decimal place to tell me if I need to keep the 3 the same or round it up to a 4. So the rule of rounding, 5 or greater, you want to move it up. So that means we're going to get the decimal 0.4. So to the nearest tenth, the athlete to student ratio is 0.4. We can also do extended ratios in triangles. And all this means is instead of comparing two things, we're going to compare 3 or more quantities. So when we extend our ratio to triangles, triangles only have 3 sides and 3 angles. So we're going to be comparing 3 quantities, not the or more. So the way we would write that, we're going to add a third variable C, and we'd write the ratio as A to B to C. So that third variable, because triangles either have 3 sides or 3 angles. So let's take a look at an example. So in a triangle, the ratio of the measures of the 3 sides is 5 to 12 to 13, and the perimeter is 90 centimeters. Find the measure of the shortest side of the triangle. What we can do is we can say that the sides of our triangle are represented by 5x, 12x, and 13x. And we know our perimeter is 90, so when I add all of my sides together, we'll get that 90 centimeters. So we can say 5x plus 12x plus 13x equals 90. Combining the like terms on the left, we get that 30x equals 90. Divide both sides by 30, and we get x equals 3. So what this tells us is, in order to get a triangle whose ratios of sides is 5 to 12 to 13 and a perimeter of 90, I have to multiply those ratios all by the value of 3. So going back to our initial question, find the measure of the shortest side, well, that comes from the shortest ratio, the smallest ratio, I should say, which is 5x. So I'm going to take the 5, multiply it by 3, and we get the shortest side has a length of 15 centimeters. We can also use this value of 3 to find the lengths of the other two sides as well. Next, let's take a look at proportions. So when we talk about a proportion, it is a statement that says two ratios are equal. And the way we usually set up a proportion is A over B equals C over D. So we're comparing two ratios and we're saying those two ratios are equal. And the way we typically solve a proportion is something called cross product. So that means is I multiply across in my fractions for my ratio. So we get our cross products of AD, and then we end up with equals BC. So I'm multiplying straight across. So A to D and B to C. Okay. Another way you can say that is that you're multiplying the extremes and setting it equal to the multiplication of the means of your proportion. So the extremes are going to be A and D, and your means are going to be B and C. So let's use this to help us solve some proportions. So we have the proportion 3 over 5 equals x over 75. So we want to find the value of x that makes these two ratios equal. So we want to multiply the extremes by the mean. So we want to cross multiply. So we're going to start by multiplying the extremes. So 3 times 75 equals the multiplication of our means. So 5 times x. 3 times 75 is 225, and we get equals 5 times x, which is 5x. Then to solve for x, we divide both sides by 5, and we get that x equals 45. So when x is 45, I get equivalent ratios. So next we have 3x minus 5 over 4 equals negative 13 over 2. So again, we're solving for the value of x that makes those two ratios the same. So we multiply the extremes by the means. So that would be 2 times 3x minus 5 equals negative 13 times 2. So basically cross multiplication. So we're multiplying across. So in this example, we have to distribute the 2 into the parentheses. So we end up with 6x minus 10 equals, and then negative 13 times, not 4, that should say 13 times 2. Sorry, not 13 times 2, it should say 13 times 4. So negative 13 times 4, which is negative 52. So now we're just solving an equation. So our first step is going to be to add 10 to both sides. So we get 6x equals negative 42, divide both sides by 6, and we get x equals negative 7. So negative 7 is the value for x that when we plug into our original proportion, we get equivalent ratios. Our last example, 2.3 over 4 equals y over 3.4. So we're going to cross multiply to solve for our value of y. So we have to do multiplication of our extremes, 2.3 times 3.4 equals the multiplication of our means. So that would be 4 times y. So 2.3 times 3.4 gives us 7.82, and then 4 times y is 4y. Then we divide both sides by 4, and we get y equals 1.955. And because we want to make sure we find exact values so that we get equal ratios, we are very rarely, if ever, going to round our final answers. So if we ever end up with a decimal that doesn't end or is repeating, we're going to try to leave our answer as a fraction. That way we get the exact answer that gives us equal ratios. But if you have a terminating decimal, such as this example, you can just write out the entire decimal for your answer. So in our last example, we're going to take a look at a word problem. So we have a boxcar on a train has a length of 40 feet and a width of 9 feet. A scale model is made with a length of 16 inches. Find the width of the model. So we want to make sure that the ratio of our length to width of our original boxcar is equivalent to the ratio of the length to the width of our scale model. So when we set up our proportion, I'm going to set it up so that we have length over width equals length over width. So when we're setting up a proportion for a word problem, we want to make sure we are setting up our equations so that they match. All right, so using this information, I know that the current length is 40 feet over the current width of 9, and when I set that equal to my scale, it has a length of 16 inches, but we're trying to solve for the width, so that would be our variable x. And then we're going to use cross products to help us solve. So we're going to multiply across. So we're going to do 40 times x. And then when we multiply going across the other way, you get equals 9 times 16. So 40 times x is going to give us 40x equals 9 times 16, which is 144. Dividing both sides by 40, we get that x equals 3.6. So this tells me that the width is going to be 3.6 inches. It is extremely important that if you set up a proportion to solve for a word problem and you have units, that you include those in your final answer so we know what you solved for. As always, let me know if you have any questions over the notes or the assignment.